Are you ready to explore the possibilities that lie beyond our atmosphere? A round of applause for Thierry.
All right. Good morning. Good morning. All right. I'm really, really excited to be here today, and I'm really excited to tell you about our vision for the space economy, and particularly the importance of networking and communication to enable that space economy. Of course, communication is really important in our everyday lives. We all know that. Can you imagine your life without your mobile phone? Can you imagine your life without access to the internet? Can you imagine how you would have handled COVID without broadband access at home and schooling and working from home? Absolutely not. So we connect billions. We connect billions of people, devices, machines, sensors every single day, globally, instantaneously. But we believe that communication and networking will very, very soon play an equally pivotal role in the space economy. Not just in Earth orbit, where we're already launching hundreds of satellites every week, but on the moon, on Mars, and beyond. The World Economic Forum and McKinsey have estimated that the space economy by 2035 will be $1.8 trillion. And we also believe that communication will be an important part of that, and more importantly, communication will be the enabler to unlock that value in the space economy. But of course, it's not easy. There are lots of challenges. How do you build a network in space? How does it even work? How do you build a network that can sustain the environmental challenges in space? How do you build a network that works 250,000 miles away from home? So we at Bell Labs love those challenges. Bell Labs is right now the industrial arm and the research arm of Nokia, but in our 100-year history, we have invented some of the most important technologies that shape how we communicate, interact, share information with each other. You are all using Bell Labs technology in your pockets today. Of course, Bell Labs invented the phone. Alexander Graham Bell, that's where Bell Labs comes from, invented the phone. We invented the transistor. Your phone has 15 billion transistors in it today. We invented the laser, optical communication. The very concept of cellular communication was invented at Bell Labs. But also on the software side, programming languages and operating systems like C, Unix, C++, and so forth. We also have a long history of communication in space. But we don't invent clickers. I don't know how this works. Okay, there we go. We also have a long history of communication in space. Back in 1962, we built the very first communication satellite. Now, you all know Sputnik as the first satellite, but Telstar was the first communication satellite, launched in '62 and enabled voice, video, and television broadcast across the Atlantic. We've also worked with NASA in the '60s and '70s on Mercury, Gemini, and Apollo programs. So now the question is, what does communication mean for the space in the next couple of decades? We believe we're really at the cusp of that innovation, and we believe that the space economy will happen. We believe the space economy will happen at scale. The $1.8 trillion economy will happen. The question is over what time frame? Maybe 10, 15, 20 years, but it will happen. We also believe that it will not happen without advanced communication capabilities. We need high broadband, high speed, low latency, reliable communication for all of that to happen. We're trying to connect machines, people, astronauts, devices, robots. All of that needs to be communicating with each other, send data, and be connected to an internet in space. We also believe that it's really important that we don't reinvent the wheel, that we don't use legacy technologies and we don't try and build completely new technologies, but rather we should be using the technologies that you and I use every day. We have the most advanced communication technologies in our pockets right now. Why are we not using those same technologies for the benefit of space? But of course, we cannot just take your phone and send it to the moon and it will work. So there's a lot of work that needs to happen to adapt the technologies that we have today, adapt them and make them suitable for space communication. So we started this journey back in 2018, and we've been working with government agencies in the US like NASA and DARPA. We've been working with commercial companies like Intuitive Machines, Lunar Outpost, and Axiom Space to do the early planning, design, development of advanced communication systems for the moon, for lunar surface communication. And we're at the edge of deploying these systems in actual missions. So I want to tell you about two particular missions that are very exciting over the next couple of years. If you're into space, you want to pay attention to these missions because there are some really historic things that will happen, not just from a communication perspective, but at large. We're part of a project with NASA and Intuitive Machines to build the first cellular network on the moon. This mission sounds very futuristic, but it's very real, and it will launch within the next few months. We're part of the Intuitive Machines 2 mission. If you're following space, Intuitive Machines 1 was the first time that the US went back to the moon in February. The next mission will go to the south pole of the moon, have a bunch of scientific experiments, look for water and ice on the moon, and prepare really the exploration for humans to go back to the moon. We're providing the communication capabilities on that mission. So I'll show you a short video of how this mission unfolds. So you see this lunar lander that Intuitive Machines built. The lunar lander will land on the lunar surface. There's a network that's connected on that lander. It will autonomously deploy, it will autonomously operate, and it will connect two robotic assets that are deployed by the lander. One is this little rover that will explore the surface of the moon, built by a company called Lunar Outpost. The second one is a hopper, which is a small mini fridge-sized hopper that will hop on the lunar surface and hop into craters on the moon and look for water and ice. And both of those devices are connected to our lander so that we can remotely control these rovers. We can get telemetry data from the rovers. We can get high-definition images, and we can get real-time videos from them. So we will move from an era of Apollo where you had black and white, very low-resolution images and videos to real-time, high-definition video that you will be able to see, and we will be able to control in the other direction, control these robotic assets. So what you see on this chart now is highlighted the Nokia network. The box that has Nokia written on it is your entire cellular network in a pizza box. It's highly compact, highly integrated from a hardware and software perspective. It is the most compact network you will ever find on Earth. We also provide custom antennas to connect these rovers to the network on the lander, and we build small device modules that go into the robots, and they're essentially your smartphones. They don't have screens, and they don't have keyboards because they're for robots, so you don't need smart keyboards and screens, but they provide the connection between the robotic assets and the network, and then all of that information is streamed back to Earth. So the second mission I want to tell you is something that we've announced just a couple of months back, that we're now also working with a company called Axiom Space to provide the same connectivity in spacesuits. Axiom Space is providing the next generation spacesuits for the Artemis program. The Artemis program is the program that NASA has to bring humans back to the moon for the first time since 1972. Really exciting program to bring first person of color, first woman back to the moon, and the Artemis 3 mission is actually the first mission that will land on the moon. It's currently scheduled for late 26, so this sounds futuristic, but it's actually very, very close to today. And we are taking the cellular technology that you have in your phone today, and we're integrating that into the spacesuit. This will allow astronauts to communicate with each other via voice. We can get telemetry data, we can get their biometric data, and we can send that to mission control. We can also have mission control communicate with the astronauts, and really interestingly, we connect the helmet camera that the astronauts have to this network so we can all see what the astronauts are seeing on the moon. And again, this is the same technology, that standard-based technology that you and I use every day, but we adapt it, we customize it, and we harden it for operation in space. And what's really important when you go to space is size, weight, power, and of course the reliability. While we have astronauts, crew time is very precious, so we cannot afford to have astronauts configure networks and debug them and fix them. This network has to work completely autonomously, completely on its own without any human intervention. So this sounds quite futuristic, but now I'll take you even a little bit further. Let's fast forward 10, 15 years from now, and I'll tell you what we think the space economy will look like. So I talked about this $1.8 trillion economy, but what does it actually do? We think when we go back to the moon, it won't be like the Apollo days where we spend a couple of days, maybe 3-4 days at most, but we believe that we create a human presence that is very sustained, permanent presence, semi-permanent presence. But it's not just astronauts being on the moon. We will also have a lot of industrial activity, whether it's resource mining, whether it's drilling, whether it's mineral extraction and mineral processing, whether it's transportation. We may have railroads on the moon. We will have power generation on the moon. We will have a lot of robots and scientific experiments that collect a lot of information that happens on the moon to increase our understanding, but also build the economy we need to sustain that presence on the moon. It is not economically viable to send everything that you need from Earth to the moon. You need to start harvesting the vital resources on the moon and create everything that you need on the moon, because it's just so expensive to send everything from Earth to the moon. Now, all of those things will require really advanced communication capabilities. Astronauts will live in expansive habitats, and just like they need water, food, shelter, life support, they will need communication to talk to each other, to talk to astronauts that are outside of the habitat, and to talk to mission control. We need high-definition video and sensors and imaging so that we can understand everything that's going on the moon. We need cameras. We also need robotic control. We have a lot of robotic activities because these missions will still be very dangerous, and you don't want to put astronauts in harm's way. So a lot of this economic activity will be driven by robots, but robots cannot perform their task if they're not connected to an internet on the moon. So all of this economy will only happen if we have advanced communication capabilities. But what's also interesting, when you think about this video and you see what the economic activities will look like, it's actually very similar to a lot of industrial environments that you find on Earth. If you look at this, how different is it from a mine in the remote area of Australia? How different is it from an oil rig? How different is it from a remote wind farm? It's actually not that different. You have people that need to talk to each other. You have machines that operate autonomously. You have devices that collect information. You process all that information. You make intelligent decisions. And yes, there will be a lot of AI. I think I made it almost through my talk before mentioning AI. There will be a lot of AI in this activity. But it's very, very similar to what we see on Earth. The very big difference is it's far away. It's a very harsh environment. So the same way that we take the technologies that we deploy in consumer networks, in enterprise networks today on Earth, we can take those same technologies to the moon, eventually to Mars, and support this activity. But what we also learn is by building these networks and adapting them to space, we bring something back to Earth. We will build the most integrated networks that we can. We build the lowest power networks that we can build. They will be very integrated, very small form factor, very lightweight, very low power, and they will operate autonomously. As I said, astronauts will not be able to configure these networks. They have to be self-configuring, self-deploying, self-healing, self-debugging, and all of those attributes are equally important when you think about the future of communication on Earth. So while we take the technologies from Earth to the moon and to Mars, and enable a future economy, we will also continue to push the innovation that will be beneficial for us back here on Earth. And with that, I really thank you very much for your attention and wish you a great rest of the show. Thank you.